welcome to our inaugural episode of Ask Erin Dear Beth, in which we tackle our first image analysis problem, uh, phrased to us as blurry images. We are going to be doing some object segmentation in some difficult images. Here, I have a folder of blurred images, image set 1 and image set 2. Does anybody can anybody provide more information about what the task is for these blurred images?
Sure, since I uploaded it, probably I can go ahead and give a context of these two folders there. Yes, there were a lot of the channels DAPI and the GP channel, the Golgi and the plasma membrane channel had a lot of blurriness. It's visible in all the channels as well, since we use DAPI and the Golgi plasma membrane for segmenting cells and the nuclei. So the main aim is to segment cell and the nuclei, eliminating all these blurriness. And the image set 1 has one set of images where we can kind of get rid of those based on size. But this image set 2 has blurriness both in GP as well, the Golgi and plasma membrane, as well as the DAPI channel. So yeah.
All right, so we are trying to segment these. We need nuclei segmented, we need cells segmented, but we're facing the issue of the blurriness is getting in the way of the ability to segment these images. So let us just, oh yeah, look at that. Okay, so here we have, just as a quick, glance at the images. It's like, here's our DAPI, and
And this looks like mostly blurriness from just cells going on top of each other, you know. Certain cell types just really don't like to sit in pretty flat sheets. They're just like all up in each other's business.
yeah, which then you have, the out of focus cells on top of, you can sort of see, uh, because you have too many focal planes going on here, but still all of the fluorescent signal visible from those multiple focal planes. Okay, so if we're going to do this in Cell Profiler, first thing we need to do is get some uh, information, name the channels here so um, we can handle them in Cell Profiler.
I don't know if we need to metadata. I don't know if we need to go that far.
Well, we have two different. Okay, we can go names and types.
I'm
So
just going to be contrary for the sake of being contrary now.
please
We
bring
have to generate drama.
yes. Okay. So we have
Channel 6.
we said channel 6 is the DAPI. So just CH6 is in the name. So we can a little bit more room to type. No more room to type.
Yeah, it will in a second. As soon as you type into it, the box will, like, if you go now to a different module and come back, the box will get bigger. It's a very frustrating refresh, but
All right. So those are DNA.
then if you hit duplicate, you'll at least get boxes with the right size.
Oh, too late. Okay. All right. All right. We'll remove this image and then duplicate this one. There we go. Okay, and the other channel to use for segmentation. So we often use RNA as a segmentation because it, like, for segmenting cells, because it's sort of bright in the inside, more concentrated towards the interior of the cell, then sort of fades out towards the edges. It sounds like Tuganyu, you're saying you were using a different channel. Those look very
Yeah, I was using RNA to identify the pre-cells and then use the
okay. Ooh,
Golgi and plasma membrane to get the boundary of the cells.
all
That
right.
worked better for the, yeah.
Which channel? These look so
Channel 2 is Golgi and plasma membrane.
okay. All right. And then channel 3 is the RNA?
Um, 1 second. Yeah, channel 3 is the RNA.
Okay. So RNA, we will. Oh, all right. That's probably enough. There we go. We've got our 3 channels with names, 2 different image sets. Okay. So, if we go into, let's just jump right into identify primary and see what happens. So, you know, many other tricks we can do, but let's just see what this looks like. So I guess another possible thing is Sugani, if you had a pipeline that got you some of the way there, we could, if you wanted
Yeah,
to.
I can share the pipeline. Like, yes, that worked for the image set 1, but the image set 2, I'm like still figuring out. I can quickly share the packet once. I can
Start test mode there. Let's see. Oh yeah, popping up on my other screen. Okay, so here's what we get without doing, without tuning anything. And you can see this looks awful, not helpful at all. So we have very over-segmented cells, and we have, or sorry, nuclei, and we have nuclei of the right sizes being filtered out. So definitely need to change things. So here, eyeball this like, okay, this is math in head, 1260 to 1320. That's 60.
Yeah. There is a measure length tool.
There is. One could do that. All right. Let's see. I should be able to count to 60 in my head, but this, that's more of Beth's expertise, the whole, math and head thing. Yeah, again, or we can no.
I have shared the pipeline if you'd like to probably use that.
Awesome. Here we can. All right. So rather than like start from scratch on tuning, let us start with something that we know is sort of working. Okay, rather than using load data. Oh, we got to go back and do this again. Okay. Gonna do this real fast. We said 6 is DNA. And then we have channel 3 RNA and channel 2. There we go. Okay. So, GP.
Well, you don't have Illum functions anyway, do you? So
Oh yeah.
I just turn all
No,
that
we
off.
can just ignore that. Okay. Thank you. Lab demonstrations. Okay. So let's see what we've got with the first image here for IDing nuclei. Okay. So here we're clearly have parameters getting a good job of finding like good nuclei, but also struggling with sort of these out of focus areas. being identified as very large nuclei. So it looks like sort of already have in here the approach of measuring the size and shape of these all nuclei, then filtering them based on size, like reasonable area size, down to keeping only the actual nuclei and moving forward with that. I think okay, so first we can talk like big picture in terms of like, okay, well, first you're saying it worked here, but it's not working on your next image set.
Yes, like based on what you and Beth suggested, I like kind of masked the objects based on the size of the nuclei. So I was able to eliminate the cells wherever it is blurred based on the bigger nuclei.
Mm-hmm.
And I also identified the secondary cells having the bigger nuclei in and later masked the objects which had the bigger nuclei. What happens in those cases is like the secondary nuclei, like since there is this work for the first image set, but the second image set, the blurriness is also super visible in the GP channel. So the secondary cells are like too big and the nuclei are not that bigger. Like the nuclei is in the normal range. So those cells are not getting eliminated. If I try to eliminate based on the blurriness in the Golgi channel, then the actual cells which are bigger with proper nuclei are also getting eliminated.
Okay. Uh, so if we go all the way through looking at the ID secondary
And then filter.
Okay, so we're back to the first image set now. So you're saying we've got something that works here. Okay. Let's see what's working. We're not back to the first image set.
We are.
Oh yeah. Okay. We are. So here, strategy was to ID primary, right? So we've got those big blobs in, then measure them, then use those to ID secondary. So here in the ID secondary, just this contrast. Ooh, not quite that much. Okay, so if we sort of zoom in, there's sort of some areas where those are, reasonable cells. And then some areas where clearly like this is a big blob of stuff. So we need this not big blob of stuff. Okay. Then the filter objects, you are filtering out the nuclei by the shape. So this is working nicely. So you have the original, all of them, and then it filters into the like keeping the nuclei and then the unwanted nuclei. Totally reasonable. And then masking objects here, what you have done is remove the unwanted nuclei.
Associated with the unwanted nuclei.
Yeah.
Because filter objects has that stupid bug in it.
Cool. So this is what's left. So that's reasonable. Like not unhappy with that function. But the idea then is in the next image set to see what is not working there. And it's not working because of blurriness in the other channels. So let's check that out. Beth, do you want to say more about the bug we currently have that is what might we do differently if there was not a specific bug happening?
We might not need to use mask objects to remove the cells from the nuclei if filter objects were not broken in terms of the filter other objects based on this first filtering. But it is.
Okay, so primary objects. We saw
Mhm.
that already. That's not unreasonable. Then secondary objects. Woo, look at that.
Yeah. So this look your one thing I noticed here is your threshold correction factor is 0.4, which is almost never a good idea to have it that low.
And
So
so
I
that,
think that's part of your trouble.
The thing is, like, I'm not able to get to the boundaries if I don't have the threshold correct, like boundaries or in the like normal images, if I don't have the threshold correction factor to 0.4 and also the lower bounds to 0.01. That's why I have this, so that in the normal looking images, this setting kind of identifies the boundaries very well. That is why I had the correction factor to 0.4 and also the lower to 0.01.
yeah. Um,
So the boundaries looked a little big on the other one too. Aaron, what is the number that you get when you sort of try to go in a little tighter on what should be sort of the real boundaries?
I mean, little tricky, again, like definitely tricky on this image because it's so fuzzy. But if we look at an area where we can sort of see like this you know, should be kind of an, well, that's funny because it looks like then the nucleus is sort of off the edge of the cell. Um, I mean, sometimes, like there's just none of this image is really actually in focus. Might be, maybe part of the problem. But if it seems like this should be tighter in up here. So sort of intensity of 0.04 something. Um, as would bring it in sort of closer to the edge of the cell. I mean, I guess, this takes us to a sort of bigger picture philosophical question of like, is it really even worth it trying to make measurements on cells in this image? Like some of it's going to depend on how precious your images are, how widespread this is across your data set. Another approach could be to, make measurements, find images that look like this, flag them and get rid of them from your measurements. Um,
Yeah.
but uh, we could certainly, yeah. So I guess that's Beth, what do you like? What would you do here?
The first thing I would do is I would go back to the working image and I would get a sense of how different the boundaries are like. Because um they were already a little loose in the other image, and so it might be that 0.04 is a perfectly fine minimum in both images. Or it might not be, but if it is, that's the easiest way to fix this problem, and I like easy.
All right, so here it looks like this is hitting the threshold
Mhm.
minimum of 0.01. But if we just try 0.04 and see what it looks like. Yeah,
Then
or
that's way too much.
yeah.
Yeah. So one option then would be to do a block-based illumination correction and try to remove some of this out of focus nonsense. I don't know how you feel about that, Aaron. I don't know what your preferred next thing would be.
I mean, my preferred next thing would probably be like find a way to identify these images and trash them. But if we're gonna like go on the assumption that this is precious data and we need to figure out how to get
Mhm.
get stuff out of them, I'm fine with that. Um, yeah, we can certainly do that. And um, so before we get into identifying primary objects, we would want to add,
I mean, you've got correct illumination calculate and apply right there.
oh,
Uh,
that I've clicked on to add a new thing. Okay.
it
Uh,
looks like once upon a time somebody did that.
yeah. Um,
Eyeballs.
you've got eyeballs. I don't know. Yeah.
Your face has eyeballs.
Okay, so and then if we, so this is sort of, what it's, taking the image, dilating it, and then fuzzing it out. And then when we apply that, so it's, going to subtract this
Mhm.
sort of dilated fuzzed image from the original image,
Mhm.
um, to then sort of
Mhm.
get rid of, in this case, the out of focus
Yeah,
light.
but I don't know that we want it for the DAPI. I think we want it for the cell image because the DAPI seems
That is doing
fine,
okay. All right. Well, then,
and that should hopefully bring the out of focus light more together.
okay. So, do, do, do. Um, okay. Well, we zoom in and adjust the contrast so it's not just a light gray blob. Okay. I mean, you can definitely see the difference before and after. Um,
Mhm. Might be a little over
well,
aggressive, but
extreme.
yeah, but I we're close. I
Okay.
would say like doubling the block size and the smoothing filter size.
And so what does the block size and smooth, like, what does doubling do, Beth?
So what that's actually doing is it's actually Sublime is actually breaking the image into individual chunks and trying to figure out the background value in each chunk, and it's subtracting that. And so the bigger your chunks are, the more likely you're truly going to get a piece of background. The more likely that what you're subtracting is actually really background and not some of your real signal. You can manipulate this so that the if you choose bigger ones, you're going to get something that is really just more of a background, just an out of focus light correction. But if there are cases where you're trying to sharpen things up, you can actually intentionally try to set a sort of smallish block size. It'll help you approximate more of like a local thresholding strategy.
All right. So here we certainly see before and after, uh, less aggressive erosion of the,
Mhm.
than last time, but does seem to be doing a lot of cleanup. Like maybe that's the
Mhm. Yeah, because if you needed to, you could then do a sort of small expansion afterward with a second round of ID secondary if this cleaned things up too much. But you'll need to now change your everything in ID secondary, adjust your thresholding strategy completely, presumably. I would
so.
start by just taking your minimum off and setting your correction factor back to 1.
mm, There's a lot of things open right now. Okay, but here, this seems right off the bat, like not unreasonable.
But this
Uh,
is the good one. So now we need to see,
yes.
did it?
But we haven't ruined anything by
No,
our approach
not ruined.
start. That's always a good starting point, right? Because before, when we tried to, when we took off that minimum, um, we were getting just the
Mhm.
tiny little spots up here. But that reasonable enough-ish from what one can tell in this very out of focus image anyway. Um, so yeah, so that's
Hard one, hard one.
okay. Let's see. Test next image set. All right. What do we got?
So hopefully this should remove more of our out of focus light so that even if the threshold that needs to change is a little bit different, they're at least now in the same regime. They're close enough to each other because we're not just measuring out of focus light, that we could use the same minimum in both cases.
All right. So if we take a peek at our let's see. I was gonna say, uh, just to see here at like what's happening in our illumination application, um, you can see it's sort of a little bit different than the previous one, where like definitely the intensity was, there were the like more smaller bright spots where you could really see the background correction like around those, and here sort of a lot more general halo across it. But this certainly looks like a much nicer starting image. Um, and if we jump to the ID secondary that we get from it, um, better, not
Definitely
perfect.
better, but I wonder if now a minimum would help a little bit. Because
Yeah.
I think we were in the 0.003 regime on the other image. So,
Yeah, this
uh,
is so we're just a little hover, like, yeah, 0.02, 0.003 is sort of out here.
mhm. So if we
Um,
did a 0.003, I bet we could clean this up a lot and not affect the other image. 3.5. Okay, just a little bit more. Turn that dial a little bit more.
we're creeping there.
Mhm.
See, this is why the art of image analysis and object segmentation.
We
Um,
should do an auction style. Can I get a
Yeah.
0.38 anyone?
You know that that big horrible one, that's a primary problem. That's not a secondary problem.
because
Oh wait, no, there is a little itty bitty nucleus there. I couldn't even see it. It was so small.
yeah, they're a little hidden in the corner. Um, yeah. Um, well, what happens? I mean, some of it also is like these are really not pretty input images. So you may end up, you may end up being in a situation where it's like, okay, I want to make sure on the best images that I'm
Mm.
getting, the best data I can. So you do want to make sure that you haven't lost any quality on sort of your better image. Um, and then, end
What
up,
if you went to local thresholding?
right, let's see. Um,
Mhm. And
where's-
then you're gonna have to pick again the Atsu 3 class.
and foreground, and it's got, all right, we think 100 is a
Sure.
starting window. So tell us, Beth, what is it like? What have we just switched to? Why would we do this?
So now we're determining the threshold independently in each block, which is going to hopefully help us in the blocks where things are sort of dimmer to force it to um, be a little bit stricter in those areas.
Some improvement, maybe?
Mhm.
Um, yeah,
It's definitely still not good, but it's certainly in a more livable range than where we were before. Now, have we completely trashed our first image back to?
that is always the question.
I love that you've made everything in Cell Profiler pink. It makes me happy.
I try and make as many things as I can pink. I still, you know, get flack from most software developers for never, never using dark mode. But also,
That still looks really good. So I would say that for half an hour of time, we've now done a much better job of sort of splitting the difference between the other one isn't great, but it's definitely now usable.
yeah,
Uh,
Thank you, Jim and Beth, for the
yeah,
support.
yeah. Thank you so much for joining us in our inaugural episode of Ask Erin Dearbeth. We hope you will join us again. In the meantime, if you have any questions for us, You can find us at the Simony Lab at the Broad Institute, simony-lab.broadinstitute.org. If you want to play around with the images and pipeline that we introduced in this episode, you can find the podcast files at simonylab.github.io/askerin_dearbeth. And you can send us your own images and or questions. We would love to help you with your own image analysis problems. Submit questions at broad.io/askerin_dearbeth.